Box and whisker plots, also known as box plots, are used to show distribution of data using a box and two lines that kind of look like whiskers. By definition, a box plot, it uses a number line and quartiles to describe a data set. That prefix quart means 4. So what it does is the data is divided into two parts. I suggest that you pause the video right now and go ahead and get this whole diagram copied down with all the details. Don't skip the number line, all the arrows, and everything. Go ahead and pause your video and get all that written down. Okay, so pointing out each of these. I have a box, and I have what looks to be whiskers going across there. There's a number line across the bottom. So these are, we're going to assume that these are ages of One Direction fan club members. What this says, it does not tell us how many people are in the fan club. It tells us the distribution of the people in the fan club. There are 5 key numbers that are plotted in a box plot. You'll hear this called the 5-number summary. First is called the lower extreme, or the least value. You'll hear other things like that. So that's the lowest number in there. So the youngest person in the fan club is a 10-year-old. Then the next number is the first quartile. It is the median of the bottom half. It's like you're taking the bottom, you half it like you're finding the median, and then you half that bottom half. You find the median of the bottom half. The third number is the median, and we know from the previous lesson we put all of the ages of members in there, and we found the middle age. The third quartile is the median of the upper half, and then the upper extreme is the greatest value. Now, since these are put into quartiles, that tells me that 1/4 of the members are between the ages of 10 and 12. Another 1/4 of the members are 12 to 13 years old. So 1/4 of the members are 12 years old. The other 1/4 is from 13 to 17, and then the upper 1/4 is from 17 to 22, with 22 being the oldest person in that fan club. So the box plot shows distribution, not number of values. It tells us nothing about how many people are in the fan club. It tells us about the spread, about the distribution of the data. Here are your steps for how to make a box plot, and we have some numbers up there. We have a data set. So the first step is to order the data from least to greatest. I'm going to go ahead and do that. And like I said in the last lesson, when you're finding median and ordering things, I suggest that you write the original list. That way you can cross them out as you use them and get it's easier to get that ordered from least to greatest. Okay, so I'm going to count how many I had in the original data set. 1, 2, 3, 4, 5, 6, 7, 8, 9. Let me count again. 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, and then when I ordered them, 1, 2, 3, 4, 5, 6, 7, 8, 9. So I didn't skip any or leave any numbers out. Second step is to identify the 5-number summary. So first we're looking for the lower extreme. The lowest number I have is 17. The highest number I have, the upper extreme, is 29. Now to divide into quartiles. Find the median first. I have 9 numbers, so 1, 2, 3, 4, 5. 21 is my median. And see how that split it into 2 other data sets. So 21 is my median. Then I'm going to find the middle of the lower half. The lower half has 4 numbers, so the median falls right in between here. So I average 17 and 19. That has an average of 18. And then for the upper half, it's falling between 26 and 28, which would be 27. So I have my 5-number summary there. Step 3 is I'm going to draw a number line. And when I'm drawing my number line, I have to think about what kind of scale I'm going to use. I need to go from 17 to 29, so I need a little bit more than 12, 13, 14 notches on there. I'm going to draw my number line. So I'm going to count that this one is 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29. Now, when you're deciding about your number line, you may want to think about possibly going by 2s or by 5s or by 10s, whatever's going to make an appropriate scale. So that's step 3, draw the number line. Step 4 is to plot the 5-number summary. Let's do a black marker for this. So I'm going to plot my 5 numbers. Here's my lower extreme. My upper extreme is 29. I have 18, 27, and 21. Okay? Then step 5 is to connect the points and draw the box. The box is for the middle 3. So I have a box from here to here. My median is there, and then draw my lines to make my whiskers. So some observations we can make about this box plot is I don't really have any outliers. The upper extreme really isn't that far from the 3rd quartile. The lower extreme really isn't that far from the 1st quartile. I have a pretty spread out data. I have a very large box there. If I had a very small box, that would show a cluster there that I have lots of data pieces right there. Next thing we're going to talk about is the interquartile range. And you'll hear this called the IQR to abbreviate. It's the difference between the 1st or the lower and the 3rd, the upper quartiles. So it's between this point and this point. So I have a lower quartile or a 1st quartile, you hear it say that, called that, a 4. And then my 3rd quartile or my upper quartile is 9. It is the difference between those, so when I subtract those, I have 5. I have an IQR of 5. It is a measure of variability. Last lesson we looked at 3 measures of central tendency, mean, median, and mode, and 1 measure of variability, range. Interquartile range is another measure of variability. It describes the spread of the data around the median. So I have 5 that are around the median. The larger the interquartile range, the greater the variability. The smaller the interquartile range, the lower the variability. You can stack box plots and compare them. So here I have 2 different airplanes. Below the number line it says the length of their flights. So the first question is, which plane has a greater median flight length? I can look straight at their medians, that middle line. Which one is greater? Airplane A. Which plane has a greater variability in flight lengths? And so we can measure variability by the overall range, the difference between the lower extreme and the higher extreme, and the interquartile range. Which one is spread out more? And that's going to be airplane B. Its interquartile range is much larger. And question C, which plane has a more predictable flight length? And that would be airplane A, because its data is pretty much the same. Its flight lengths are never lower than 180 and never higher than about 203 or so. Basically a 20 minutes difference in flights. It's very predictable. Where for airplane B, it could be anywhere from 160 minutes to 205. That is a much bigger difference. So airplane A is more predictable. For your practice, you are going to be creating a box plot. So look up on your notes, look at those how-to steps that I gave you on how to create your box plot. Go ahead and pause the video, attempt this, and then compare with what I've done. Okay, there's your box plot. You want to check your 5-number summary. It's always good to write those out so that you can easily check for errors when you're comparing. Has a lower extreme of 8, upper extreme of 39. The median is the middle number, 15. Lower quartile, the first quartile is right between 8 and 10, which is 9. Upper quartile, third quartile is between 18 and 23, which is 20.5. Upper extreme, 39. Plot each of those 5 points and draw the box. You can tell that your data is clustered more in the teens, and it is skewed to the right. It's skewed toward 39. That is an outlier that's pulling the data that way.